Okay, yesterday we talked about sequences. Sequences, we have two different types of sequences right now. We have arithmetic and we have geometric sequences. We're dealing with an arithmetic. We've developed a general formula to calculate nth term. To determine some nth term of a geometric or arithmetic sequence, we have our first term, our Tn, whatever term that you're looking for, is equal to your first term plus your common difference times n minus 1. And this is what we developed yesterday with respect to how, turn phones off. Okay, how we developed this yesterday, improved this yesterday, how we can determine an nth term. And when we're talking about a geometric series to find this nth term, we take our first term times r to the n minus 1 power. Take our first term times r to the n minus 1 power. These are the two formulas that you can utilize to be able to determine and manipulate through. I gave you different types of problems in here where if you had an arithmetic, you may have to find some other part to, I may give you an nth term, the first term, and I may give you a term number and you had to calculate the difference, or I may have you find what was that term number that you had to deal with. So you had to find different parts to the equation rather than just finding whatever the nth term is. Solutions were provided for you. Questions, problems you need me to go through? Yeah.
Number 6 on the end of it, it was negative 5 over 2. Can you just explain that about that?
How I got negative 5 over 2.
Yeah.
All right, we have to write a general formula. We have a geometric. We have a geometric, and we have a common ratio of negative 2. And how we find that common ratio is we take the term and divide by a previous term. So negative 10 divided by 5, or 20 divided by negative 10, negative 40 divided by 20. That will give us our common ratio of negative 2. So we have a geometric. Our Tn is equal to T1 times r to the n minus 1 power. Well, my T1 is a value of 5. So we have 5, and we have a common ratio of negative 2 to the n minus 1 power, which most of you probably got to this point and then had trouble getting to that next point. How do I get my solution? Well, if we take a look at this negative 2 to the n minus 1 power, and we use our properties of exponents, this is negative 2 to the n minus 1 power, which is negative 2 to the n plus a negative 1 power. Okay, we're just using a little boom chain there. We have minus 1 is plus a negative 1. Which, using our properties of exponents, we have, when we have x to the a plus b power, this is x to the a times x to the b. And this goes in both directions. This is our properties of exponents. We have x to the a times x to the b. We add our exponents together. Well, what we have is we have a plus b, so now I can separate this into negative 2 to the nth times negative 2 to the negative first power. All I'm doing is using my properties of exponents here. So if I look at negative 2 to the negative first power, negative 2 to the negative first power, once again, going back to our properties of exponents, x to the negative a power is 1 over x to the a power. So this 2 to the negative first power can be written as 1 over negative 2. So what we have now is we have negative 1/2 here. This negative 1/2 is a factor now. I can multiply my 5 times negative 1/2 to give me negative 5 halves, and then negative 2 to the nth power. So I did not perform any mathematical black magic wizardry here. I actually used the properties of mathematics and exponents to be able to simplify. So there's no witchcraft going on here. And wave the magic wand and poof, it happened. Okay, just use properties of exponents. Good question to ask though, because a lot of people don't remember our properties of exponents. Other questions? Yeah.
The first 4, I was
Yeah.
confused on how you got the first term.
The first term?
Because when if there's the first term, you do 1 minus 1 to get, and that would just come out to 0, right?
For which?
Like for number 1, I had 7 as the first term. I think you had 10.
Yeah, because, all right, when I have T1, this tells me my n value is a value of 1.
Oh, I thought you just did like 1 minus 1.
No. Oh,
So I was looking at
you went up to this right here.
Yeah.
I've given you the general formula there. I gave you Tn is equal to 3n plus 7. So I already give you that. So I'm not giving you a list of terms. If I gave you the value 5, 7, 9, 11, then I would go back into that formula here. But I'm already giving you the general formula here. So I'm just telling you n is a value of 1. When I'm looking for T1, that means n is a value of 1. So I have 3 times 1 times plus 7. It takes a little bit getting used to the nomenclature. It's just a little bit different. Okay, it's once you start using it time and time again, you'll get used to the nomenclature and how things are written. It just takes a little time to get to that point. Other questions? All right, today we're going to talk about what's called they call them explicit formulas. I don't know why. We're going to talk about what is called a recursive formula today. The recursive formula is more how our brain works in regards to sequences. And it's also how we looked at some sequences yesterday. I gave you a list of terms in the sequence and asked you, how did you get from one term to the next term? That's how our brain works a lot of times. We don't typically go into the formula idea. But today what we're going to look at is the recursive formula, which once again is a little bit more how our brain works. If we look at T1, this is the first term in the sequence. T2 is the second term in the sequence. Okay, because my subscript is 1, my subscript is 2. Tn is the nth term of a sequence. Okay, I'm looking for some nth term, the 20th term, the 50th term, the 80th term, the 100th term. Whatever that term number is, that's my Tn. But then we have this Tn minus 1. It's the previous term to any term in the sequence. The nth term is some term of the sequence. The Tn minus 1 term is the previous term to that nth term. Suppose the nth term was the 100th term, so that's T100. That means n is equal to 100. That's my 100th term. That's my 100th term. Well, what would be the previous term to the 100th term? Well, that would be the 99th term. The previous term to that 100th term would be T99, which would be the 99th term. I could subtract 1 from my term number and to get my previous term. That's my term right next to it. That's the term right before it. So if we take a look at a sequence here, we have 5, 2, 5, 8, 11, 14, 17. What's our fourth term here? Justin, what's our fourth term?
11.
11. Yeah. N equal 1, 2, 3, and 4. That's my fourth term. But if I take a look at my previous term, my previous term to T4 would be which term number? Okay? Term 3. So this would be term 3, would be T3. Or we can write this as T4 minus 1 to give us T3. So I could subtract 1 from a term to get to my previous term. In the previous term, what do you have to do to a term to get to the next term? Paige, what do you have to do to a term to get to the next term here?
By the difference, like the different number.
Yeah, what do you have to do to get to 5, 5 to get to 8, 8 to get to 11? What do we have to do here?
Add 3.
We have to add 3. We have to add 3. So when we start looking at a recursive formula for a sequence, it is a formula that's designed. We design a formula to use a previous term formula designed to use the previous term to determine the following term. It's a formula designed to use the previous term to determine the following term. So we use that previous term to get to that next term. We also need to have an initial condition, which is your first term. You need to know where to start this. So there's two parts to a recursive formula. And once again, this is a little bit more how our brain works. Because we are designed in our brain to figure out a pattern. What are you doing here to get to here? What do you do here to get to here? What am I doing to the next previous term to get to the next term? That's how our brain works a lot of times. So if we take a look at this recursive formula up above here, we can find Tn, some term, is going to equal our previous term plus 3. Because that's what we're determining here. To determine a term, we could take our previous term and just keep adding 3 to it. We just keep adding 3 to the previous term to get to our next term. But what we also need to note here is we need to know an initial condition. We have T1 is equal to 2. You need to know where to start. So if I now look at what I'm dealing with here, my T1, my first term, is a value of 2. Okay, that's my first term. Okay, let's take a look what happens here. If I look at T2, that means my end value is 2. If I put an end value of 2 in here, this gives me my T2 minus 1 power, or 2 minus 1 subscript, plus 3. Well, the 2 minus 1 subscript gives us T1 plus 3. Well, my T1 is a value of 2, so I have 2 plus 3, which is a value of 5. To find T3, or if I put an end value of 3 in here, if I put an end value of 3, this would give me T3 is equal to T3 minus 1 plus 3, which gives me T2 plus 3. So it takes my previous term, which is T2, which is 5, plus 3, which gives me the value of 8. If I try to find T4, n equals 4, then I have T4 minus 1, which is T3 plus 3. So it just keeps on. Once again, this gives us our previous term. What do we have to do with our previous term to get to my next term? And we have the initial condition that we have to start out with. Because if I started my initial condition at 7, then I would have a different sequence here. I'd have 7, 10, 13, and so on. Basically, what you want to think about here is, and this is once again how our brain works a little bit more. What do you have to do the previous term to get to the next term? You must add 3 to get to the previous term. If we look at the next one here, we have 9, 5, 9, 13, 17, 21, 25. We want to write a recursive formula here. Well, let's figure out what the pattern is. Do we have arithmetic or geometric? Janae, do we have arithmetic or geometric? Arithmetic, common difference of what? 4. Common difference of 4. So if we take a look now to find some nth term n, what do we do to the previous term to get to our next term? We add 4. So we have Tn plus 4, n minus 1 plus 4. And then we also, once again, need to get our first condition here. T1 is equal to a value of 5. Okay, once again, you need to have 2 parts of this. You have to have your formula, but you need to know where to start. You need to know what T1 is. What would be the recursive formula to the initial condition for the following sequence? Arithmetic or geometric? Rachel? Geometric, what's our common ratio then? I'm sorry, what? 2. Ratio is 2. Take a term, divide by the previous term. 10 divided by 5, 20 divided by 10. So if we now take a look at our term, Tn, what do we have to do to our previous term to get to our next term? What are we doing in each case to go from term to term, Ella? No, you get other direction. We're not to go from 5 to 10, multiply by 2. So we have 2 times Tn minus 1. Sure.
Are you good with these?
Maybe.
Okay. Mine, the exact same as this one. We're doing linear regression, tells me the correlation coefficient. When they're typing it in, it doesn't. It just gives them A and B. And I looked at all the modes, everything looks the same.
Some of them are programmed. This is an older version here.
But they're both TI-80.
I know. Some of them are programmed differently.
I bought this in probably 2005. I bought these this year.
They program them differently. I don't know why. I don't know why that happens.
So how can they find the correlation coefficient? They just can't?
Not through the calculator. You have a formula that you can apply.
That's not number one though.
I know that.
It says just via
I
technology.
know. Trying to think if there was.
So I went through and I matched all the modes other than degrees. I don't think that mattered.
Trying to think if there was.
Oh, I don't know.
Give you the same thing.
Yeah. Oh, there it is.
There you go.
So what was that, the test?
Okay, you go over the tests.
Stat over the
You go to
test.
tests and go down to your linear regression test.
Okay.
Yeah, see, it's scroll down here.
Then,
And just go down to calculate. And you're gonna have to scroll down.
so there's still the A and the B, and then there's the R. Okay, thank you. Sorry, class.
Great job, Mr. Green.
So if we take a look now once again, we need to get our initial condition here. We need to still remember to get our T1 is equal to a value of 5. Okay, we need to know where we start. Okay, so if I have my T1 as 5, to find T2, we take 2 times T2 minus 1, which is 2 times T1, which gives us 2 times 5, gives us 10. Given the recursive formula, what are the first 4 terms of the sequence? What are your first 4 terms of your sequence? So what we're saying is n is equal to 1, this gives us T1, n is equal to 2, this gives us T2, n is equal to 3, this gives us T3, n is equal to 4, this gives us T4. What are your first forms of the first 4 terms of the sequence? Okay, the first little hiccup that tends to happen with this, when I ask you the first 4 terms, is T1, you want to plug values into the formula already. T1 is already given to you. T1 is a value of -2. So you do not have to do anything to find T1 because I give you T1 up here. Okay, that's a hiccup that occurs because people get stuck. Oh, I got to plug -2 in to get my first term. No, your first term is -2. It's given to you. To find our second term, we have to take 2 times this -2. I'm sorry, how about 3? 3 times this -2, which is the previous term, plus 5. So we have 3 times -2, which is -6, plus 5, which is -1. To find my third term, we need to take 3 times our previous term, which is -1, and then add 5 to that. So we have -3 plus 5, which is a value of 2. To find our fourth term, we have to take 3 times our previous term, which is a value of 2, plus a value of 5. So we have 6 plus 5, which is 11. So our first four terms is -2, -1, 2, and 11. The question is this arithmetic, geometric, or neither? Do we have a common difference or a common ratio? No. So this is a neither. If we take a look at the first four terms of the next sequence, we have 4, Tn is equal to 4 times Tn minus 1. Once again, don't get hiccuped into T1 is already given to you here, and I have to find something. T1 is already given to you as a value of 3. This one's a little bit easier. Ethan, what do you have?
3, 12, 48, 192.
Okay, if we take a look at this sequence, what type of sequence do we have here? Arithmetic, geometric, or neither? Geometric. What's our common ratio? Our ratio is a value of 4. So we have geometric ratio is a value of 4. When you're dealing with a geometric ratio or a geometric sequence, and we're talking about a recursive formula, what this will fall into is this common ratio times T n minus 1. This value of 4 turns into a coefficient to the previous term. And once again, think about it this way. What am I doing to my previous term to get to my next term? I'm multiplying by 4. Okay, once again, how our brain works. If we look at the next one here, Tn is equal to Tn minus 1, T1 is equal to plus 5, T1 is equal to 6. So what's T2? T3 and T4. Sarah, what's your first four terms?
6, 11, 16, and 21.
What type of series is this, or sequence is this? Arithmetic, common difference
5.
is a value of 5, and if we take a look there, there's our value of 5. So when you're talking about a recursive formula, we have Tn is equal to Tn minus 1, whoopsie, plus this common difference. And that will work for any gem or arithmetic sequence. Once again, what are you doing to a previous term to get to the next term? That's once again, as I talked about, how our brain works a little bit more when dealing with sequences, because we try to figure out patterns. That's what our brain tries to look for, is what's the pattern here? What do we have to do here? What's the rule that we have to do to go from one thing to another? Now, today's worksheet gives you a combination of both of these recursive and explicit formulas. So you'll be using both the things from yesterday and also today. For example, if you take a look at the first problem. Okay, you have 5, 12, 19, and so on. You need to determine what type of sequence is it, and then apply the formula to find the 501st term. Okay, so that's going to give you Tn is equal to T1 plus Dn minus 1. But if we take a look at problem number 5, down on problem number 5, or let's go to 3. Problem number 3. Now I give you a recursive formula. Now I want you to find the 301st term. Well, I have Tn is equal to Tn plus minus 1 plus 7. I know I have to add 7 to my previous term to get to my next term, but how do I find that 301st term? So what I would suggest you do when you get recursive formulas, what I suggest you do is write out the first 3 terms. We have, in problem number 3, we have T1 is 21. To get to my next term, I have to add 7. So we have 28 and then 35 and so on. Now it's in the form that you have in problem number 1. Now we can find what is my common difference is a value of 7. I want to find T301, which is equal to T1 plus D times 301 minus 1. I can throw my value of 7 in there, and I know my first term is 21. If you can pull that off of the equation without having to write it out, that is fine. But a lot of times, I find it easier in my brain just to write out the first 3 or 4 terms to make sure I know what type of sequence I have there. And then I can apply my formula I need to apply. The explicit formulas is what you did for today. The recursive formulas is what we did today. Tomorrow we'll deal with series, and then we'll work on just practicing, going back over these ideas over and over again the rest of this week. Okay, so tomorrow we'll just add one more thing into this, and then we'll go and just practice, getting used to the idea of series. All right, questions? Rest of the time is yours.